Alright, team. Sorry I have to be gone again. I'm going to be gone today and tomorrow, and I'll be back on Wednesday. And we'll continue our discussion of implicit differentiation and 3D graphing and multiple variables and all of that awesomeness. But while I'm gone, I want to assign you guys an art project. So you guys were talking about 3D graphs and how you thought they were cool, and I think they're cool as well. And you can see here I just have an example of one that I pulled up. So hopefully you're watching this on your own computer and you can pull up Grapher and play around. Basically what I want you to do for the next 2 days is play around and make something really beautiful. Like, I kind of like this, but I wish it was a little bit neater. So I might, like, I don't know, do something like make it to the square root and do something crazy like that. Yeah, I kind of like that. You know what? I want to see more ripples. So I'm going to play around with the cosine and put in like a 9 here. Yeah, I'm liking that. So now we're talking here. And I can smooth that out and stuff if I really want to. I'm just showing you now how to play around with these sorts of things. So let's see if we can see our contour lines here. I can hollow out my shape so I can just have my grid if I want to. There's all sorts of awesome things you can do. You can up the resolution so that it looks really nice, or nicer anyway, and then refresh it. As you can see here, it looks really nice, but then it's going to cause your computer to get a bit laggy. So anyways, I kind of like this stuff. So feel free to play around with this kind of thing and make something that you really, really like. What I want you to do when you've built something that you like the look of, I want you to make a sculpture out of it. And what I mean by that is literally, let me show you, is make a contour map out of it. So take slices of it, like this picture right here at the very top. Take slices of your object at certain z values and figure out how wide they are in the x and y value. So plug in something for z and figure out what x and y are. And then actually cut pieces of paper, or cut pieces of cardboard, and go ahead and go down to the office and steal some cardboard from like the tissue boxes, and actually cut slices. So make the purple slice and make the this magenta slice and this fuchsia slice, and then all the way up to the orange ones, and kind of stack your object, or build it sideways if you want, and then kind of glue or tape them together. And feel free to paint them or do whatever. But I really just want you guys to get a feel for how to make these kinds of graphs. So to be clear again, your assignment is to pick a z level. Maybe this one would be better if I cut it up the other way. But pick a z level and figure out what x and y are and slice this thing like you're putting it on a meat slicer into little slices that you can then glue together. Okay? And the thickness of your cardboard will be the next step in z. So if your thickness of your cardboard is 1/4 of an inch, then go over a 1/4 z or 1 z or whatever you want to do with that. Before you get going with that though, I want to just give you a quick little game to play so you can get used to how 3D graphs work. Whoops. I would like you to try to graph the following without looking on the internet what the equations are, because obviously if you Google it you can just find it, but the purpose of this is for you to kind of lift with your mind and think about, how would I graph in 3D a cone? How would I graph in 3D a helix, right? Or maybe even a double helix, right, for DNA. So can you do these things without just Googling the answers? And of course, work together and talk to each other. Can you graph an ellipsoid, right, like a football? How about a cube? That would be crazy. Maybe a cup. How about some mountains, kind of like what I have here? And then basically just do whatever you want. So feel free to rewind the video and take a look at these, of course. So again, your assignment is to produce a kind of tiered contour map of your shape. And some of you are going to have questions. Feel free to work together. I basically just want this shape in real life made out of stacked slices of cardboard. So however you want to get that done, that would be just fantastic. The sub should know that you're allowed to leave the room. And feel free to go snag as much cardboard as you can. Don't cut up anything in my room that has stuff stored inside of it. I'm sure you can get a lot from the kitchen and the office and places like that. Alright guys, well I hope you have fun with this over the next 2 days. I'll miss you guys a lot. If you need help just doing problems, you should be working on the implicit differentiation. Let me write that down. If you just want to work on some problems from stuff from the last couple weeks, implicit differentiation is the chapter we just finished. That's the X and Y stuff, but only in 2D. And then we'll be moving into related rates and optimization if that's what you if you want to try and get ahead while you're working on this project. Okay? All right. Well, I'll see you guys on Wednesday. Feel free to email me or send me a message on Facebook if you need some help. Thanks.